In the grand theater of the cosmos, there are scripts that have been meticulously rehearsed, and then there are those that throw out the script, abandon all expectations, and improvise. What if the most deeply ingrained ideas about the nature of our universe are turned on their head? Welcome to the realm of improvisation in physics. Today we're diving into a question that might just rewrite the laws of the cosmos. What if dark matter does interact with light? Before we dive in, I want to address the elephant in the room. Dark matter is called dark because it doesn't interact with light or any other form of electromagnetic radiation. It's like the shy kid in the corner of the cosmic playground. We know it's there because of its gravitational pull, but we can't see it directly. But what if this cosmic recluse is not so dark after all? What if it's been hiding in plain sight, disguised as darkness? Our current understanding of dark matter suggests that it's a type of matter that permeates the entire universe, making up roughly 80% of all matter in the cosmos. It's an invisible substance that exerts a gravitational pull, holding galaxies together and influencing the large-scale structure of the universe. Despite its elusiveness, scientists believe that this mysterious substance plays a pivotal role in the evolution of the cosmos. But what if this fundamental aspect of our universe is completely wrong? What if instead of being dark, non-interacting, and invisible, dark matter is actually shining brightly, influencing the universe in ways we've never imagined? Brace yourself, because this journey will challenge everything you thought you knew about the universe. A kaleidoscope of cosmic structures. If dark matter particles could suddenly emit or absorb light, our view of the cosmos would change dramatically. Galaxies would no longer be just islands of stars. They would be surrounded by beautiful glowing halos of dark matter. These halos would not be static. They'd dance and shimmer as the dark matter particles move around. Even more mind-blowing, if dark matter were to interact with itself through a new force mediated by these new particles, it could form intricate filamentary structures throughout space. And it's not just about reshaping our view of galaxies. It would completely revolutionize our understanding of the large-scale structure of the universe. Those vast cosmic webs of galaxies would take on a new three-dimensional appearance. The filaments, sheets, and voids of the universe would either shine or darken, depending on how the new force manifests itself. But let's shift our focus to the early universe. After the Big Bang, and before the formation of stars and galaxies, the universe was a sea of particles, mostly protons, neutrons, and photons. Dark matter, however, was also present in this primordial soup. If dark matter were to interact with light back then, it would have scattered off those photons, leaving an imprint on the cosmic microwave background radiation, the CMB. This is the afterglow of the Big Bang that still blankets the universe today. With this new interaction, the CMB would reveal a kaleidoscope of new patterns and features. Gone would be the smooth, almost featureless background radiation that we observe today. Instead, we'd see a dynamic interplay between the dark matter and normal matter, giving rise to a cosmic tapestry woven with the threads of light and darkness. By studying these new patterns, astronomers could piece together details about the early universe that are currently shrouded in mystery. They could learn more about when and how normal matter and dark matter began to clump together under the influence of gravity. And they could shed light on the role that dark matter played in the formation of the first stars and galaxies. It would be as though we were looking at the universe through a brand new set of eyes, seeing not just what is, but also what was and what could be. And what's more, we might not even need new telescopes to make these discoveries. By analyzing existing data, such as the patterns of the cosmic microwave background radiation and the distribution of galaxies, astronomers could potentially uncover evidence of these new interactions. However, the implications go far beyond just the early universe. It would challenge our understanding of the present-day universe and force us to rethink some of the most fundamental concepts in astrophysics. For instance, the exact distribution of galaxies within galaxy clusters would be different, and features of the interstellar medium, such as the famous pillars of creation in the Eagle Nebula, would be dramatically altered. Even phenomena as grand as supernovae and the formation of neutron stars and black holes would be subject to change, possibly occurring in ways that we've never even imagined. In essence, it would be like playing a game of cosmic what if, except the stakes are much higher. The rules of the universe itself could be rewritten. Unveiling new particles and forces. But how could something so fundamental to the universe be so drastically different from what we observe? The answer lies in the very nature of dark matter. As we know it, dark matter is a mystery, an enigma that has puzzled scientists for decades. It's like trying to catch smoke, grasping at an idea that seems to slip through your fingers. But what if instead of being this elusive, almost intangible substance, dark matter is made up of particles that interact with each other and with light in ways we don't yet understand? This simple shift in perspective opens up a Pandora's box of possibilities. If dark matter were to suddenly start interacting with photons, it would reveal the existence of a new fundamental force of nature. This force would be similar to the electromagnetic force that governs how light and matter interact in our everyday world. However, it would have unique properties, a signature that would distinguish it from the familiar forces of electromagnetism, gravity, the strong nuclear force, and the weak nuclear force. This new force would likely be mediated by a new particle, something akin to a photon, but one that carries the dark matter charge. Let's call this particle a dark photon. The existence of such a particle has been hypothesized before in various models of particle physics, but it's generally considered to be extremely elusive, almost impossible to detect with current technology. However, if dark matter were to begin interacting with light, it would mean that these dark photons are being produced in abundance, making them detectable with the right instruments. The discovery of the dark photon would be monumental, ushering in a new era in our understanding of the universe. It would mean that the standard model of particle physics, which currently describes all the known fundamental particles and their interactions, would need to be expanded. This new framework would include not only the dark photon, but also new types of dark matter particles. These particles would have electromagnetic properties, meaning they would be able to form things like dark atoms or even more complex structures. It would essentially be like having a second periodic table, one that describes the properties and behavior of these hypothetical dark matter particles and their interactions. In fact, the idea of dark matter forming atoms and molecules has been explored in numerous scientific papers. Some researchers have even gone so far as to suggest that these dark matter structures could have played a significant role in the early stages of star and planet formation. These hypothetical dark atoms would be incredibly difficult to detect because of their lack of electromagnetic interaction, but their gravitational effects could potentially be measured. If confirmed, this would open up an entirely new branch of astrophysics, one that studies the properties and behavior of dark matter at these atomic and molecular levels. Such a discovery would not only revolutionize our understanding of the universe, but it would also lead to some exciting possibilities for future research. Imagine being able to study the structure and dynamics of dark matter in a laboratory setting. Imagine being able to probe the fundamental nature of this mysterious substance and unravel its secrets. For now, it remains in the realm of science fiction. But who knows what the future may hold? The more we learn about the universe, the more we realize just how much there is to discover. Rethinking the cosmos. Observing the invisible. If dark matter were to emit or absorb light, it would open up new avenues for observation, enabling us to see the invisible. But how would we go about doing this? It would require a fundamental shift in the way we approach astronomy and astrophysics. Currently, we rely heavily on electromagnetic radiation, specifically visible light, radio waves, X-rays, and gamma rays to observe celestial objects and phenomena. However, if dark matter were to reveal itself through light, We would need new instruments, new telescopes capable of detecting the specific wavelengths of light emitted or absorbed by dark matter. These telescopes would not be like anything we have ever built before. They would have to be incredibly sensitive, able to detect minute variations in the faint glow of dark matter. Moreover, they would have to be positioned in strategic locations, either in space or on Earth, to minimize interference from other sources of light. For instance, a telescope designed to detect the specific wavelength of light emitted by dark matter would need to be shielded from the much brighter light emitted by stars and galaxies. This could be achieved by placing the telescope in a deep space mission away from the galactic plane, or by building it deep underground where it would be shielded from the Earth's atmosphere and light pollution. But it's not just about building new telescopes. It would also require a complete overhaul of our current methods of data analysis. Astronomers would need to develop new algorithms and techniques to sift through the massive amounts of data that these telescopes would collect, searching for the telltale signs of dark matter. Moreover, it would necessitate a paradigm shift in the way we observe the universe. Currently, we rely on direct observation, on collecting electromagnetic radiation from distant objects and decoding the information it holds. But if dark matter were to reveal itself through light, we would need to develop new methods that go beyond what we can see. We would need to find indirect ways to measure its presence, perhaps by observing its gravitational effects on visible matter or by detecting the annihilation products of dark matter particles. And the impact wouldn't be limited to just astronomy and astrophysics. It would also force us to rethink some of the most fundamental concepts in physics. Take gravitational lensing, for example. This is a technique that uses the gravitational field of massive objects like galaxies to magnify and distort the light from objects behind them. It's like using a cosmic magnifying glass to peer into the depths of space. If dark matter interacts with light, it would mean that our current models of gravitational lensing would need to be reevaluated. We might find that many of the data sets we've analyzed and interpreted through the lens of current physics would need to be revisited and reinterpreted in light of this new development. In essence, it would be like turning on a new setting on our cosmic cameras, revealing details that were previously hidden from view. And it's not just about what we've observed in the past, it would also shape our view of the future of astronomy. All the telescopes and observatories being planned and constructed would need to be modified to take into account the potential for dark matter to interact with light. This could mean incorporating new detectors and instruments to search for dark matter signals or redesigning entire missions to optimize their sensitivity to dark matter's unique glow. In a way, it would be like building a new set of eyes for humanity. Eyes that can see beyond the visible spectrum and into the realm of dark matter. So what do you think? How would you go about observing dark matter if it started interacting with light? What would be the most surprising revelation for you? Share your thoughts and join the cosmic conversation. Together we can explore the infinite wonders of the universe, one intriguing question at a time. And remember, the universe never ceases to amaze. There's always something new, something unexpected waiting to be discovered. And if you've enjoyed this episode, make sure you hit that like and subscribe button to keep updated on any new videos. Stay curious, stay open-minded, and keep asking questions. Who knows what wonders we might unveil next? Keep looking up.